Hello everyone. We'll see the next method to find inverse Laplace transform, that is convolution theorem, a very important theorem. So the statement is, if Laplace inverse of f of s is f of t, we need two functions here. So Laplace inverse f1s is equal to f2t and Laplace inverse of f2s is equal to f2t. Then Laplace inverse of f1s into f2s is integration 0 to t f1u into f2 t minus u d. First Laplace inverse of f1s, first function of s, we'll call it as f1. It is your choice for which functions you will call first and you will call second. So f1t and f2t you have to find, and accordingly you have to write integration formula as integration 0 to t. For first function we have to write u in place of t, and in second function you have to write t minus u in place of t. Okay, you'll understand once we take the example. So example, find Laplace inverse of 1 upon s plus 3 into s plus 5 by convolution theorem. If it is particularly asked by convolution theorem, then this example can also be solved by partial fraction, but we will not solve it by partial fraction as it is particularly asked by using convolution theorem. So for convolution theorem there is combination of two functions. So we'll call f1s and f2s to two functions. So f1s is this is multiplication of 1 upon s plus 3 and 1 upon s plus 5. So one of the function we'll call f1s and second function we'll call f2s. So f2s is 1 upon s plus 5. Then we have to find Laplace inverse of f1s, that is Laplace inverse of 1 upon s plus 3, and it is e raised to minus 3t. Next we have to find Laplace inverse of f2s also, that is Laplace inverse of 1 upon s plus 5, and which is e raised to minus 5t. So first function Laplace inverse f1s we will call it f1t, and for second we will call f2t. So this is your function f1t and this is your f2t. Now it is your choice, we can call f1 to this also and f2 to this also. Okay, then by convolution theorem, Laplace inverse of f1s, okay, I'll write the formula first. f1s into f2s is equal to integration 0 to t f1u into f2 t minus u du. That is Laplace inverse f1s, that is 1 upon s plus 3 into 1 upon s plus 5 is equal to integration 0 to t f1u. In this f1t, this is your f1t, in that we have to put t as u, so we get e raised to minus 3u into f2t minus u, this is your f2t, in that we have to write t minus u in place of t, that is e raised to minus 5 into t minus u, and this integration with respect to u is there. So that is integration 0 to t e raised to minus 3u into e raised to minus 5t into e raised to 5u du. As integration is with respect to u, function of t is constant, it will come outside e raised to minus 5t. Integration 0 to t e raised to 5u minus 3u, that is e raised to 2u du, that is e raised to minus 5t into e raised to 2u upon 2 from 0 to t, that is equal to e raised to minus 5t by 2 into e raised to 2t minus e raised to 0, that is 1. And then your final answer will be like, we can stop here. This is your answer. Okay, we'll take next example. Find Laplace inverse of s square upon s square plus 9 into s square plus 4 pi convolution theorem. So we have to first find two functions, multiplication of two functions in this. So we'll write f1 as is, as there is s square, that is 2s, so I'll give 1s to first function, and f2s is s upon s square plus 4. Try to write such functions whose standard formulae of Laplace inverse are known. So we'll first write Laplace inverse of f1s, that is equal to Laplace inverse of s upon s square plus 9, that is cos of 3t, and Laplace inverse of f2s, that is Laplace inverse of s upon s square plus 4, that is cos 2t. We'll call first function is f1t and second function is f2t. Therefore, by convolution theorem, Laplace inverse of f1s into f2s is equal to integration 0 to t f1u cos 3u into cos 2t minus u du, that is equal to, okay, that is Laplace inverse s square upon s square plus 9 into s square plus 4, which is equal to integration 0 to t cos 3u into cos 2t minus 2u du. This is of the form cos A cos B. We have a formula for 2, so we'll adjust that to 2 cos A cos B is equal to cos 2 cos A cos B is cos A plus B cos 3u plus 2t minus 2u plus cos A minus B, that is 3u minus 2t plus 2u du. That is 1/2 integration 0 to t cos 3u minus 2u, that is minus, u plus 2t plus cos 5u minus 2t du. Okay, then we'll write the integration. Integration of cos is sin u plus 2t upon derivative with respect to u, that is 1, plus sin 5u minus 2t upon 5 from 0 to t, that is equal to 1/2 sin upper limit, if it is t, the t plus 2t sin 3t plus sin 5t minus 2t sin 3t by 5 minus lower limit, if u is 0, that is sin 2t, and plus sin minus 2t by 5. That is equal to 1/2 into sin 3t plus sin 3t by 5 minus sin 2t, sin of minus theta is minus sin 2t by 5, and that is equal to 1/2 sine 3t plus sine 3t by 5 minus sine 2t plus sine 2t by 5. That is equal to 1/2 1 plus 1 by 5 sine 3t, that is 6 by 5 sine 3t, and this is minus 5 plus 1, that is minus 4 by 5 sine 2t, and thus your answer will be 3 by 5 sine 3t minus 2 by 5 sine 2t will be the required answer by using convolution theorem. Okay, we'll take one more example. Find Laplace inverse of s upon s square plus a square bracket square by convolution theorem. So consider f1s as there is only s in the numerator, so it will go to only one function, and this is twice, so it is 1 upon s square plus a square, and second function f2s is s upon s square plus a square. So multiplication of 2 will be the function. Therefore Laplace inverse of f1s, that is equal to Laplace inverse of 1 upon s square plus a square, that is nothing but 1 upon a sine at. And second Laplace inverse of f2s, it is Laplace inverse of s upon s square plus a square, which is cos at. We will call this as first function f1, and this is your f2t. Therefore by convolution theorem, Laplace inverse s upon s square plus a square bracket square is equal to integration 0 to t f1u, that is 1 upon a sine a u, into f2 t minus u du. As there is 1 upon a constant, we will take it out, that is 1 upon a integration 0 to t sine au into cos at minus au du, and this is of the form sin a cos b. We have a formula of 2 sin a cos b, so multiply and divide by 2. So we get 1 upon 2a integration 0 to t to sin a cos b is sin a plus b au plus at minus au plus sin a minus b. That is equal to 1 upon 2a integration 0 to t sin au minus au cancel, sin at plus sin au plus au, that is 2au minus at du. Now this integration gets separated as 1 upon 2a integration 0 to t sin at du plus integration 0 to t sin 2au minus at into du. That is 1 upon 2a integration of sin at du with respect to u, and it is function of t, so it is constant. It will come out of integration, so sin at integration du plus integration 0 to t sin 2au minus at du as it is. that is 1 upon 2a sin 80 into integration du, that is u, this is from 0 to t, plus integration of sine, that is minus cos 2au minus at upon 2a, and this is from 0 to t. So it is equal to 1 upon 2a sin 80 t minus 0. Here it is minus outside, so it is cos, upper limit is t, so cos 2at minus 80, that is 80 upon 2a minus lower limit if u is 0, so minus cos of minus theta, u is 0, so it is cos of minus 80, that is cos 80 upon 2a. That is, these two get cancelled here, and it is just 1 upon 2a into t sin 80. So answer will be t upon 2a sin 80. We take next example. Find Laplace inverse of 1 upon s square into s square plus 9 by convolution theorem. Here f1s is 1 upon s square and f2s is 1 upon s square plus 9. So Laplace inverse of f1s will be Laplace inverse of 1 upon s square, that is t, and Laplace inverse of f2s is Laplace inverse of 1 upon s square plus 9, that is 1 upon 3 sin 3t. Here I will call this as f1t and this as f2t, because in your second function you need to change t by t minus u, so it will be a simpler function to change to t minus u than this. So by convolution theorem, Laplace inverse of f1s into f2s, that is 1 upon s square into 1 upon s square plus 9, is equal to integration 0 to t f1u, that is 1 upon 3 sin 3u into f2t minus u, that is t minus u du, that is 1 upon 3 outside as constant, integration 0 to t, we'll open it, t sin 3u minus u sin 3u du. This part will get separated in the integration, that is 1 upon 3 integration 0 to t sin 3u du minus integration u sin 3u du, that is 1 by 3 t constant outside, integration 0 to t sin 3u du minus, this is as it is, integration 0 to t u sin 3u du, 1 by 3 t integration of sine, that is minus cos 3u upon 3 from 0 to t minus, here are two functions of u, so we'll use Leibniz rule of integration. So this is your u and this is your v, so it is u v1 integration of sine, that is minus cos 3u upon 3 minus derivative of u, that is 1, integration of cos is minus as it is sin 3u upon 3 into 3 9 from 0 to t, that is equal to 1 upon 3, that minus sign I'll take out, 3 I'll also take out, minus t by 3 cos 3 t minus cos 0, that is 1. Then minus upper limit is t, so it is minus t cos 3t upon 3. Then minus minus plus sin 3t upon 9. This is upper limit minus lower limit. U is 0, so 0 into anything is 0, and sin 0 is also 0. That is equal to 1 by 3 into minus t by 3 cos 3t minus 1 minus plus t cos 3t by 3 minus sin 3t by 9. That is equal to 1 by 3 minus t by 3 cos 3t minus plus t by 3 plus t cos 3t by 3 minus sin 3t by 9, and here these two terms get cancelled, so it is 1 by 3 into t by 3, that is t by 9 minus sin 3t by 27 will be the answer. There are some exercises for you, so try to solve them. Find Laplace inverse of s square upon s square plus a square square. Second, Laplace inverse s square upon s square plus a square into s square plus b square. Third, Laplace inverse of 1 upon s into s square plus 4. Next, Laplace inverse 1 upon s plus 5 into s minus 4 square. All of them by convolution theorem. Thank you.